Good afternoon, class. We're going to pick up working on this test 1 review. Solve the quadratic inequality and write the solution set at interval notation. Well, we used something called the cut point method to solve inequalities. And I think these problems have just kept appearing at the end of homework assignments all semester long. So hopefully you remember the steps to the cut point method. The first thing you do, you ask yourself, when is the inequality equal? That's a quadratic equation. I think we can factor it. X squared, well, that's just an x times x. 28. Let's see. 1 times 28. 1 times 28. 2 times 14. 4 times 7. I think that's it. The last sign's a minus, so we're going to have one of each sign. We have 1 plus and 1 minus. Which pair are we going to use here? This is a simple trinomial. It's called a simple trinomial because picking out the correct pair is simple. What are we going to use? You choose the pair, in this case, that subtracts to give you 3. Okay, so 4 and 7, a plus 4 and a minus 7. Positive 4 minus 7, sure enough, that gives us that minus 3. Setting each factor equal to 0. We get negative 4 and positive 7 for my solution cut points. For solution cut points, they'll either be labeled open or closed circles. In this case, which one is it? What do you look at? Okay, right there. There's no equality, so you don't shade in these things. The solution cut points will be labeled with open circles. I don't like that. That looks like a negative 40. I'll put the little open circle right there. They're going to be labeled with open circles. The second step, denominator cut points. What do we conclude? I knew something about denominator cut points when I wrote that problem down. What did I know? Will we have any denominator cut points? No, because there are no fractions. So, there are no denominator cut points. Third step, you draw a number line. You label your cut points. First of all, make sure you put them small to big, so it's negative 4 on the left and 7 on the right. And we said they'll be open. Step number 4, we have to check intervals, but I don't think we're going to have to check every one of these intervals. When you look here, the original problem had a square, but did we have any perfect square factors? When we factored, did we get x plus 4, x plus 4, or x minus 7, x minus 7? They're distinct factors, therefore I'm confident that the intervals are going to alternate. It's only if you have perfect squares. Well, 28 isn't a perfect square, so there's no way you could have had perfect square factors there. I think I'm going to test 0. That's my favorite number to test. Which interval contains 0? Interval 1, 2, or 3? 2, right there. I'm going to test 0. Plugging it into the original inequality, we get a 0 squared minus 3 times 0 minus 28 is greater than 0. 0 squared is 0, minus 3 times 0 is 0. So really all we have is negative 28 is bigger than 0. True or false? False, so we cross out that interval. That means if we had tested something like negative 5 or negative 10 over here, what would we expect? Shade or cross out? Shade, I agree. And that keeps on going to negative infinity. Suppose we checked 8 or 10 over here. What do we expect? Shade or cross out? There were no perfect square factors, so I was confident that the intervals would alternate. By alternate, I mean you don't have 2 consecutive true or 2 consecutive false. When I knew the middle interval was false, that meant the intervals beside it both had to be true. Fifth and final step, interval notation. Call it out as if we were writing it, typing it into MyLab. Parentheses or bracket.
Parentheses.
Are we going to have any brackets?
No.
No, because there's no closed circles. So parentheses.
Negative infinity, comma, negative 4, parentheses, u, open parentheses, 7, comma, infinity, parentheses.
I agree. Negative infinity, comma, negative 4, close parentheses, union, Any questions? Go back to. I test. It can happen if there are perfect square factors. In the old days, we would say they'd have multiplicities that were even. Once we're through with this review, I'll make up one where it's either a true, true, false, or a false, false, true, because it can happen. Depending on whether, you have to have perfect squares in the original problem, so it can be factored as something like x plus 4 times x plus 4, or x minus 7 times x minus 7. If you wind up with the same thing in both sets of parentheses when you factor, you need to test every interval. Okay? But that doesn't happen in your class on this, but theoretically it could happen. Number 16. Okay, let me write the problem down. Now when we're going through factoring it, if we wind up with the same thing in both sets of parentheses, test every interval. Okay? Okay. 2x squared minus x is less than or equal to 10. It's another cut point problem. That's the only way we solved any inequalities in this class. We'd ask ourselves, when is it equal? And I'd move the 10 over to give me 2x squared minus x minus 10 is equal to 0. And now we're going to try to factor. 2x squared, well, that's a 1x times a 2x. What do we know about the signs? The last sign's a minus, so 1 plus and 1 minus, I'll fill that in a moment. Now for that 10, 1 times 10 or 2 times 5. Here you can't just look and know, oh, well, they got to add or subtract to give you that number right there. Up here, I knew I had to choose the pair that subtracted to give me that 3. So there it was pretty, I could pick it up. Why is it different? That leading coefficient here is a 1. That's a simple trinomial, and it is called a simple trinomial because it is simple to factor it. This one here, it's not simple to pick out. It's either going to be a 1 and a 10 or a 2 and a 5. Well, 1 and 10 are, 9 units apart. Look at that number right there in front of x. The outer and inner have to combine together to give us a negative 1x. So I think we better try the 2 and the 5. If I'm going to use the 2 and the 5, can I put the 2 here? No, because then you have the same factor inside the set of parentheses. You can't have a common factor inside the parentheses if you're factoring it correctly. If you put a 2, both terms are divisible by 2. So I'm going to put the 5 here, the 2 there. Now play around with it. The outer and the inner have to give you that negative 1x. You need 1 plus and 1 minus. Where do we put the plus? Where do we put the minus in order to get back that negative 1x? A plus 2, I agree, and a minus 5. And you can check x times 2x. Here I am checking. That's 2x squared. Outer, x times a negative 5. That's a negative 5x. Inner, that's a positive 4x. Last, 2 times negative 5 is a negative 10. Negative 5x plus 4x, what does that give us? Does it give us back that negative 1x? Yes, it does. So there's the factorization. Set x plus 2 equal to 0 to give us x equals negative 2.
Ryan, I'm going to ask you a question. Is it going to alternate, or do you need to test every interval?
Did we get
the parentheses? Did you get the same thing in both sets of parentheses when you factored it?
Did you get x plus 2 times x plus 2? Did you see any perfect squares up here? No.
So you don't have to test every one of them. It'll alternate. The only way it might not alternate is if you have the same thing in both sets of parentheses.
Now I'm going to try to rush so we have time to do one like that.
I'll be quiet.
So move the 5 over to give me 2x equals 5, and x equals 5 over 2. For my 2 solution cut points, how will these cut points be labeled? Open or closed? Closed, because there is equality, so they're going to be closed dots.
So they're going to be brackets.
They'll be brackets, that's right, in the interval notation. What about denominator cut points? Well, there's no fraction there, so there's no denominator cut point. We'll draw our number line. I bet you the next problem will have denominator cut points. Be sure to arrange these cut points in numerical order. Negative 2 goes to the left of positive 5 halves. Close circles. So there are no repeated factors, so I'm confident that the intervals are going to alternate. I'm going to test 0. Where is 0 located? Interval 1, 2, or 3?
Label it negative infinity here and positive infinity there. 0, is it between 2 negatives? Between a negative and positive? Or between 2 positives? Yeah.
Right, here's 0.
0 is always between a negative and a positive.
So plugging in 0, 0 squared is 0 times 2 is 0 minus 0 is less than 10. True or false? True. 0 is less than 10. So we shade. What do we do here?
Cross it out.
Here?
Cross it out.
So our final answer, written using interval notation, bracket.
Negative 2, comma, 5 over 2, bracket.
So we go to the My Lab and we type in the answer.
Oh,
bracket, -2, comma, 5 over 2. Get out of the denominator before you close off the bracket. Any questions there? Here's an inequality, another cut point problem. Do you expect there to be denominator cut points in this problem? Yes, because you see that the problem has denominators. There's a fraction, so you expect a denominator cut point there. So, number 17, we have 20 divided by x plus 4 is less than or equal to 5. Switching over. First thing we do, we ask ourselves, where is it equal? Here's my first step. 20 divided by x plus 4 is equal to 5. I'd get rid of that denominator by doing what? Okay, so we multiply both sides by x plus 4. Multiply by x plus 4 to give us 20 equals. I distribute the 5 to give me 5x plus 20. Oh, this is working out sort of interesting. I move this 20 over to the left. 20 minus 20 will give me 0 equals 5x. Divide by 5. So, 0 divided by 5, I have a solution cut point of 0. How will this be labeled on the number line? Solution cut points, you look back at the original problem, and what do you conclude? Open or closed circle? Closed circle because there is equality. The second step, the denominator cut points. This is the first time we've had a denominator cut point on this review. It's the first inequality with a fraction. You don't want the denominator to be 0. X plus 4 cannot equal 0. You don't want a denominator of 0 because 20 divided by 0 is undefined. So x plus 4 can't equal 0. That means x cannot equal -4. How are we going to label this denominator cut point? Denominator cut points, you don't look back at the original problem. Denominator cut points are always labeled the same way. What is it?
Would you open circle?
Open circle. Right there you're saying you don't want x to be that number, so you can't shade it in. You're saying don't use that number.
Denominator cut points are always open circles.
Step number 3, we draw a number line. We have 0 and -4. Be sure to put them in numerical order. -4 is smaller than 0. 0, it's closed. -4, it's open. Are we going to have to check every interval, or can we just check one and assume an alternating pattern? Look at, did we even have to factor in this thing? There were no squares. When you're factoring something, when you're factoring, you have exponents. Did any exponents even pop up here? Everything here is linear, just x. So there's no repeated factors because we never even had anything to factor. So what can we conclude? Will we have to check every interval, or can we just check one and assume an alternating pattern? You can always check all of them. That's always the safe thing to do. But in this case, there's no repeated factors. You didn't even factor here. There were no x squares. We can assume an alternating pattern once again. Now,
I think we're having too much trouble with that. For your purposes in this course, it's always going to alternate. Okay?
So I can't check 0. How about, give me another number that's easy to plug in. 2? Where's 2? To the left of -4, between -4 and 0, or to the right of 0? Here, so I'm going to test 2. That would give us a 20 divided by 2 plus 4 is 6 is less than or equal to 5. If we had tested 1, I think it would have worked out a little better. 20 divided by 6, that's 10/3. 10/3, that's what, 3 1/3. If you think of it as a mixed number, it's 3 1/3 is less than 5.
That is true.
True.
Mm-hmm.
So we shade.
That means in between -4 and 0 can't possibly be it, so we cross that out and shade infinity to -4.
So
Negative infinity.
if we had tested -1, it'd be false. If we tested -5 or -10 over here, it'd be true. So, interval notation. Let's write this interval first. Oh, there's step 4 where we're checking. Step 5, interval notation.
Parentheses, negative infinity, comma, -4, parentheses, then we do bracket because it's shaded in.
That's
0,
right.
Comma, infinity, parentheses. Because infinity and negative infinity can't be bracketed.
That's right. Typing in. Oh my goodness, another one. Number 18. Solve the inequality x minus 11 all over x minus 14 is greater than 3. First thing we do, we set it equal. Where does the left side equal the right side? What do you think I'll do to solve that equation? Okay, multiply by the denominator, x minus 14. The x minus 14's cancel, leaving me x minus 11 is equal to 3x minus 3 times 14 is 42. We're trying to solve for x, so I'd move that x over to the right, try to minimize my negatives. 3x minus 1x gives me 2x. Notice, am I having to factor here? As I'm going through this, do I have to factor? Do I have any even exponents appearing anywhere in the problem? No. So this thing's not going to alternate. It's going to alternate. It's not going to be a true, false situation. I'll be able to just check one interval and assume an alternating pattern. I'll add 42. Negative 11 plus 42 gives me a positive 31. Divide both sides by 2. That gives me a solution cut point of 31 halves. Will this be an open circle or a closed circle on the number line? Open because there's no equality. Will there be a denominator cut point? Yes, because I see a denominator. We don't want that denominator to be 0. X minus 14 cannot equal 0, so x cannot equal 14. How do we always label denominator cut points? Regardless of the original problem. Denominator cut points, do you ever want them shaded in? No, so you always use an open circle. Draw our number line. Okay. Which one's smaller, 31 halves or 14? 31 divided by 2, that's what, 15 and a half? So 14's smaller, it goes first. And then 31 halves. Open circles for both of them. Once again, I thought of 31 divided by 2. That's 15.5 or 15 and a half. So 31 halves is bigger than 14. And let's see. We didn't get any repeated factors. We didn't even get any even exponents. We didn't have to factor anywhere, so I'm 100% confident. If I were guessing, it's either true, false, true, or false, true, false. So, what's my favorite number to test? 0. Hey, I have a question. Why didn't I test 0 over here? Here I tested 2. Why didn't I test 0?
Because of the fact that 0 was part of the equation.
Okay, 0's a cut point. You can't check a cut point. So, which interval contains 0? Interval 1, 2, or 3? Interval 1, so we're going to test 0 over here. That'll give me 0 minus 11, so negative 11 divided by 0 minus 14 is negative 14. Is that bigger than 3? Negative divided by negative, a positive 11/14 is bigger than 3. True or false? Keep in mind 11 over 14 is smaller than 1. It's false. So now that brings up a good point. If you're only checking one interval, you better make sure you check that one interval correctly. This is false, so we'll cross that out, which means this middle interval, what will I do? Shade, I agree. Here, cross. Final answer, will I have any brackets? No, because it's open circle, that's parentheses, 14 comma 31 half, right parenthesis. Any questions there? Okay. Oh, it's an absolute value inequality. So number
less than or greater than, so we're going to do cut point. Will there be a domain cut point, or a denominator cut point? No, there's no fraction. Y'all remember how to solve the absolute values equations? You go equal positive equal negative.
So first thing we do, we replace the absolute value, replace the inequality with an equal to. So That's the absolute value of 10 minus 4x equals a positive 7. Which numbers have an absolute value of positive 7? What number could you have in here so that when you take the absolute value, you get a positive 7? 7 or negative 7? So you set 10 minus 4x equal to positive 7. 10 minus 4x equals negative 7. Move the 10 over, so that says negative 4x is equal to 7 minus 10 is negative 3. Divide by negative 4 to get x equals 3/4. Negative divided by negative becomes positive. Here, subtract 7, that says
subtract 10.
Subtract 10, that says negative 4x is equal to negative 7 minus 10 is a negative 17. Divide by negative 4 to give us x equals positive 17/4. Will my solution cut points be open or closed circles? Closed because there's equality, so they're closed. We'll be labeling them with closed circles. What do we conclude about denominator cut points?
None.
Because there's no fractions, so we draw our number line. Put those numbers in numerical order. 3/4 is first, and then 17/4. We said they'd be closed. So, do we need to check every interval, or can we assume an alternating pattern? Do we see any even exponents? Do we get any repeated factors, perfect square factors? No, so we can assume an alternating pattern. I think I'll test 0. Which interval contains 0? Interval 1, 2, or 3?
Interval 1.
So I'm testing 0. That says the absolute value of 10 minus 4 times 0 is 0. So the absolute value of 10 is less than 7. The absolute value of 10 is 10. Is 10 smaller than 7? So cross that out, which means here
That has to be.
and here.
No.
So we have a bracket, 3/4, comma, 17/4, right bracket. Okay.
Want me to do it?
Now you need to try to get your voice better. Number 20. Solve the inequality and graph the solution set on a real number line. We have the absolute value of x squared plus 4x minus 25 is greater than 20. Let me make sure I didn't miscopy this. The absolute value of x squared plus 4x minus 25 is greater than 20. Okay.
No denominator cut points.
There are x squares, so we have to be careful. We're going to wind up factoring. We want to make sure we don't wind up with x plus 5, because if we have repeated factors or perfect square factors, That's when we need to check every interval. First thing you do, you replace the inequality with equal to give me x squared plus 4x minus 25 equals 20.
Most people would skip that step, I suspect, and go straight to
the absolute value equals 20. That means the step in here, to equal 20, you have to have either 20 or what? Negative 20. So you set x squared plus 4x minus 25 equal to positive 20, or x squared plus 4x minus 25 equal to negative 20. Solving the first one, we need to move that 20 over by subtracting. That'll give us x squared plus 4x. Negative 25 minus 20 gives me a minus 45 equals 0. Here's the important factoring part. Are we going to get the same thing inside both sets of parentheses? X squared, that's x times x. What do we know about the signs? The last sign's a minus, so we have 1 plus and 1 minus. I think a plus 9 and a minus 5 will give us back that plus 4x. Notice 9 times negative 5 gives us the negative 45. Did we get the same thing inside both parentheses? No. So I'm thinking we'll be able to just check one interval. If it's a perfect square, that's when you wind up needing to check all of the intervals. Setting each factor equal to 0, we get x equals negative 9 and x equals positive 5 from our first two solution cut points. Now, add 20. That'll give us x squared plus 4x. Negative 25 plus 20 gives us a minus 5 equals 0. We're going to factor again. Factoring. X squared is x into x. What do we know about the signs? Okay, the last sign's a minus. So how about a positive 5 and a minus 1? Does that give us back the plus 4x that we need? So, did we get the same thing inside both sets of parentheses? No, we didn't. So once again, I can look here and I know I only need to check one interval. I can assume an alternating pattern. So we have x equals negative 5 or x equals positive 1. Setting those two factors equal to 0. So we have a total of 4 solution cut points. How will these solution cut points be labeled? They're all going to be either open or they're all going to be closed. Which one? Open, I agree, because there's no equality. Draw your number line. 1, 2, 3, 4. Make sure you put these numbers in numerical order. The smallest number is negative 9. And then negative 5, positive 1, and positive 5. What's my favorite number to test? 0. Which interval contains 0? Interval 1, 2, 3, 4, or 5? I agree. 0 is between negative 5 and positive 1.
A couple of months ago, I made the joke that at the end of the semester, if someone asks you, what did you get out of Mr. Precella's algebra class? You can say, well, I can locate 0 on the real number line.
I know the only thing I learned is you test for 0.
Well, at least test 0, but if you just say, I can locate it, well, anyone can locate 0 on a number line.
0 0 squared is 0. 4 times 0 is 0. So we have 0 plus 0 minus 25. So the absolute value of negative 25 is greater than 20. Be careful. True or false? True. You have to take the absolute value of negative 25, and that's a positive 25. So that is a true statement. Good. That's true. What am I going to do here? False. Here. Shade. Shade or cross out?
Cross out.
Cross out. And here?
You'll notice there's a lot of these cut points on this first test. You might get into your head that this is something, a major part of college algebra. And it is. It's something very significant. How to solve an inequality. So, write it out, Tim.
Am I going to have any brackets here? No, because there's no closed circles. Everything's parentheses. Parentheses negative infinity, comma negative 9. Union, negative 5, 1. Union, 5 to infinity. Let me mark out that parenthesis. That little check mark I made there. That's sort of in the way.
I'll punch it in here.
Left parentheses, negative infinity, comma, negative 9. Right parentheses, union. Left parentheses, negative 5, comma, 1. Right parentheses, union. Left parentheses, 5, comma, infinity. Right parentheses. Put it back on my paper. Ryan, look back here where you're factoring. That's the thing that tells me whether it's going to alternate or not. And this is all alternating. That's what I mean. We didn't have x plus 9 times x plus 9, or x minus 5 times x minus 5. If you have repeated factors, that's when you want to check every interval. But every factor is different. And you say, well, suppose there aren't any factors, no x squares, then you can automatically assume an alternating pattern. Look at number 19. There were no x squares. There was nothing that you even had to factor. Number 18, the same way. Just x's. No time did we have to factor. Okay? Number 20.
No, oh wait, we're not finished.
Remember, a parenthesis is the same thing as an open circle. So looking at my graph, or looking at the graph you have there, I think it's A, isn't it? Mm-hmm.
Okay. Finally, 21, no cut point. Finally.
Okay. For the points P and Q, find the distance from P to Q and the coordinates of the midpoint. Point P is at the point negative 8, comma 14. Point Q is at the point negative 3, comma 17. So what do they want first? Distance or midpoint? I think they want the distance. Remember our distance formula. The distance from 2 points is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. The first point you think of as x1, y1. The second point you think of as x2, y2. Okay, x2, what's going to go here? Negative 3, x1, well, it's a minus and negative 8, and you're right, that's going to become positive. y2 here, 17, and here, 14, negative 3 plus 8, that minus a negative became a positive, negative 3 plus 8, that's a 5, so we have a positive 5 squared plus 17 minus 14 is 3, so you have a positive 3 squared. That's a 25 plus 9. 25 plus 9 is 34. 34 is not a perfect square, and there are no perfect square factors of 34 other than 1, and that wouldn't change anything. So our distance is the square root of 34 units. Now the midpoint. Oh, go ahead and type in that distance. Now we need the midpoint. Remember, for the midpoint, you average the x values and you average the y values. That's all you're doing. You're averaging, that means you're adding them up, divide by 2, add them up, divide by 2. You're averaging. If someone asks you, how are you finding the midpoint? You average the x values, you average the y values. Negative 8 plus a negative 3. You're adding the x values, and now you're going to add the y values. 14 plus 17. Negative 8 plus negative 3, that's a negative 11 halves. Negative 11 halves is midway between negative 8 and negative 3 on the x-axis. That's what you're finding. What number is midway between the given x values? 14 plus 17, that's 31 halves. 31 halves is midway between 15 and 17 on the y-axis for my final answer. Let's see. 31 halves. One more. This is the last one. For the equation y equals x squared, create a table with at least 3 ordered pairs that are solutions to the equation, and then graph the equation. I don't know that we need to write this out. I think y'all can just help me by calling out the y values right here. Plug in negative 2 for x. Negative 2 times negative 2, what am I getting for my y value?
Positive 4.
I agree, a positive 4. Plug in 0.
0.
0 squared is 0, I agree.
4.
And 2 times 2, 4, I agree. And now they want us to graph the equation. I'm going to pop that graph out right there. And you got to click the graph and choose the tool that you're going to be using. Now before I did that, I should have asked, y equals x squared. That's quadratic. So you're going to be graphing a quadratic. What's the name of that figure that you're going to get? A parabola. If you hover right over each thing, there it says 3-point quadratic tool, and that's what we have. We have 3 points and it's quadratic. So I'm going to click that tool, and it says plot the first point. Oh, what was the first point? I can't see it. It was a negative 2, positive 4. There's the first one. And then 0, 0. I can see that there. 0, 0. And finally, 2, 4. You save it, and that will transfer the graph to the original grid. Check answer. Any questions there? Okay. Well, that's the end of that first test review, so I'm going to stop recording.